Section 5.4 talks about imaginary numbers, which I hinted at in our last lesson. Imaginary numbers, so I represents imaginary numbers in math. And what I means is it's the square root of -1. So if we have the square root of -4, we basically break that down to being -1 times 4. So the square root of -1 is I, the square root of 4 is 2, so this equals 2i. So the square root of -4 is 2i. Easy. We're using I to represent the negative sign. So basically, as soon as we see that negative sign, we just pop it out as an I. There are, you'll get into powers of I later on, and so I just want to introduce very quickly how that works. So if I is the square root of -1, I squared would be the same thing as -1. And I cubed would be the same thing as I squared times I. Well, that's the same thing as I squared is negative 1 times I, right? So that is the same thing as -I. And I to the fourth is the same thing as I squared times I squared, which is the same thing as -1 times -1, which is the same thing as 1. So I's always follow this pattern. I is the square root of -1, and that's just, we just start there. I squared would then have to equal -1 because the square root of -1 times the square root of -1 would give you -1. I cubed equals -I, and I to the fourth equals I, or 1, positive 1. Now what you'll realize is that when you get to I to the fifth, or I to the sixth, or I to the 54th, doesn't really matter. I to the fifth is I to the fourth times I. Well, I to the fourth is 1, so it's 1 times I, so it's I. I to the sixth is I to the fourth times I squared, which is 1 times I squared, which is I squared, which is -I, or -1. So all of these, once you get past 4, I to the fourth power, once you get past it, they all reduce back down to I to the first, I squared, I cubed, or I to the fourth. They all reduce. So I to the 54th, let's see, that would be like I to the fourth times I to the fourth times I to the fourth. And how many times would that happen? That would happen 13 times, because 13 times 4 is 52. So you have I to the 52 times I squared. Well, I to the 52 is just 1 times 1 times 1 times 1 because it represents I to the fourth over and over again. So this just equals I squared, which of course equals -1. So you need to realize that I, when you take it up in powers, it repeats in cycles of 4. It gets to 4 and it starts over again. It gets to 4 and starts over again. All right. So they go over here and they define this as the square root of -x is the same thing as I times the square root of x. That should make sense because I represents the square root of -1. Easy. Now, a complex number is a number that you have a real number and a imaginary part. And this is usually represented by a plus bi. And that's usually how we represent them, where a is our real part and b is our imaginary part because it's multiplied by I. Now, you'll find this happen a lot with the quadratic equation where you'll get 3 plus or minus, maybe 4i over 8 or whatever you have. So this would be a complex number up here because you have a real part and an imaginary part. The important thing to remember about these, though, is that complex numbers, we deal a lot with conjugates. And you want to look that up on page 190 at the bottom. It says complex conjugates. So if we have a plus bi, and we have a minus bi, let's just take a look at what that does here. Let's go ahead and multiply these out. So we would get a squared. By the way, you should immediately see this as the difference of two squares, because the difference of two squares, like x minus 2, x plus 2, that would be x squared minus 4. We just square the first one minus square the second one, but we're going to go ahead and do this out just for fun. I feel like my pen's getting a little light, so I'm changing colors. We get a squared minus abi plus abi minus b squared I squared, right? So these cancel because you have minus ABI and plus ABI. So you get A squared minus B squared I squared. Well, what do we say that I squared was? I squared is the same as negative 1. So what do we have here really? We have A squared plus B squared. How I got that was I said A squared, this became A squared minus B squared times negative 1. Well, negative B squared A squared minus a negative B squared would be A squared plus B squared, and this is our answer. This is what we get. So with imaginary numbers, it's very important to understand the difference of two squares formula, which is how you've seen this before, how you see it now, and what it really means. With imaginary numbers, you can use this formula, difference of two squares, to actually do the sum of two squares as well. But again, you get imaginary answers. All right, so let's just go through one example. Example number 1, we have x squared minus 10x plus 34 equals 0. What we want to do is we want to, they say, solve it and check one of the solutions. So to solve it, I can't factor that. I'm going to have to use the quadratic equation. So I need the opposite of b, which is a positive 10, plus or minus the square root of b squared, which is 100, minus 4 times a, which is 1, times c, which is 34, all over 2a, which is 2 times 1. Easy. So what do I get? I get 10 plus or minus. So what is this, 132? Negative 132? So I should have negative 32 back there. Is that right? I'm trying to think. 4 times 4. No, sorry. This is 16 carry the 1, 136. So this would be 36. So it would be plus or minus the square root of negative 36 over 2. So that would be 10 plus or minus 6i over 2, which is the same thing as 5 plus or minus 3i. That's our answer. I'm going to write it up here. 5 plus or minus 3i. Now, when they say check that answer, and they want you to check it. Oh, I'll just erase my equation. What they really want you to do is substitute that in and make sure that it works. So I'm going to take this. I'm going to take one of them. Let's go ahead and just do 5 plus 3i. I'm going to check this one. I'm going to put that in for my x. So I get 5 plus 3i squared minus 10 times 5 plus 3i plus 34 equals 0. Now when you do all that math, that should work out as true. You should get 0 equals 0 or 4 equals 4 or something like that. But it's some tedious work, but you should totally be able to do it. And they also have the work written out in the book, so you shouldn't have an issue. Good luck with 5-4. Homework is in the Google Doc.